But for the large cap stocks, your $1 would have grown into 58. Obviously, something should be different between the small stocks and large stocks. Otherwise, everybody would buy the small stocks, right? We know that not everybody is buying the small stocks. CAPM basically says small stocks should be riskier, all right? And I'm going to do the overall risk. We'll, we'll look into beta and stuff in next chapter. The overall standard deviation. stdev is the name of the function. And I'm going to divide this by 100 as well. This is monthly, but doesn't matter too much. Obviously, they're riskier than what you want to call the whole thing, the large cap stocks. Now, I'm not technically using beta, but these portfolios are pretty well diversified themselves, so they shouldn't have much in idiosyncratic risk. So if CAPM is correct, the ratio of these two should be a straight line, right? Or alternatively, let's do a graph of these two. Insert, use this scatter graph stuff. No, not even that. Just regular. Okay. This doesn't say too much. First of all, I'm going to move this chart to a new sheet. And I'm going to put these things into different scales. And you can always right click on a series, hit format data series, and I'm going to put this on secondary axis. When you do a two chart scale like that, if CAPM was correct, these guys should have landed on the same line. Obviously, it's not going to be exact, but they are not on the same line. Or alternatively, let's and this is called trainer ratio. Technically, you do this with the risk premium divided by that, but it's not going to matter too much. Let's get rid of this. All right. This is my trainer ratio. I'm going to put that into a different scale because scales are widely different. Let's make this a different color. I'm going to make that yellow, a little bit thick. And I'm going to also make the background of the chart area something like grayish, or maybe black. I don't know. so that the better visibility. Oh, that's the trainer ratio. That guy is supposed to be flat, but it's not. Okay. It basically says the rewards that you get for the large caps is a lot higher than it should be. Okay. Uh, Actually, technically speaking, I do also need the risk premium. Let me also bring that in just a second. Under here, Farmer French 3 factors, we can actually get the data for risk-free rate and market. So let's do this. From these, I'm going to deduct the average of the risk-free rate. Yeah, a little bit better. Standard deviation of that is not going to matter too much. Okay. But either way, it's not a straight line. Again, we're going to talk about these more on chapter 8. In fact, if you estimate the betas and calculate the Sharpe ratio based on those, you find out that the risk premiums for smaller stocks, historically speaking, they're higher than what is justified by beta differentials alone. That means there is something else is going on. And this kind of leads us to, again, we'll spend more time on this on chapter 8. Historically, there seems to be a size premium. Smaller stocks earn returns that are higher than justified by their beta. And similarly, there is a value premium. Firms with low market to book ratios have higher returns than justified by beta differentials alone. There's also momentum anomaly. If you did a similar exercise every December. Instead of buying the smallest 10, you buy the 10% of the stocks that did the best over the previous year and keep holding that.